Hello, my name is Mr. Asprey and this is Edexcel IGCSE and this is number 47, Algebraic fractions. If you don't know, I split up all of the IGCSE into 60 topics and I've made exam question videos on each of these topics, and I've actually done it twice. This is my second set of questions, and if you're watching this in 2025, then I have a revision session live in April, which I highly recommend you check out. Link in the description, because I'm going to be going over some of the toughest type questions in order to help you get the best possible grade, particularly if you're going for a grade 9. Okay, algebraic fractions is one of those tricky topics. What we need to do is find a common denominator, and we've got to factorise as much as we possibly can. So I'm going to be talking a lot about common denominators when we're adding or subtracting fractions, and I'm going to be talking a lot about factorising when we're trying to simplify fractions. Let's get into it. So this is a question where we need to subtract, or when we subtract or add, we have to find a common denominator. So we've got to think, what denominator can we make here? And the lowest common multiple between these two things is 8x. So I'm going to write 8x, and I'm going to write minus 8x. So this one here we need to times by x, so I need to do that to the top as well. So that gives me 7x. And this one here I need to times by 2. So I'll put that in brackets and I'll times it by 2. So I'll write here 2 lots of x plus 3. Okay, great. So now what we can do is we can write the numerator out as 7x minus 2 lots of x plus 3 all over that common denominator of 8x. Because when you add fractions, we don't need to change the denominator, we just add the two numerators as long as the denominator is the same. Okay, so this gives me 7x, and when I multiply out this bracket, I'll be really careful that I must distribute the minus 2 to both terms. So minus 2 times x is minus 2x, and minus 2 times plus 3 is minus 6. And that's all over 8x. And then we just simply simplify the numerator, because 7x minus 2x is 5x, and then we've got that minus 6 there. We check the numerator. Can we factorise that in any way? No, we can't. And if we can't factorise, it means we can't simplify. So that is our final answer. Bosh. Okay, next question is similar because we are adding, so we need to find a common denominator between these three denominators, and the lowest common denominator is 4x. So I write 4x plus 4x plus 4x. Now, what do I need to times this one here to get 4x? So I've got to times it by 4. So I do the same to the top, and that gives me 12. What have I got to times this by to get 4x? I've got to times it by 2. So I'll do the same thing to the top in brackets. And this will give me 2 lots of x plus 2. And then this one over here, I need to times by x. So I need to times 1 by x on top, which just gives me 1x. So now I can write it all over the common denominator of 4x. And the numerators I add. So I have 12 plus, I'll multiply out these brackets as well at the same time. I get 2x there, and I get plus 4. And then plus the x at the end as well. Okay, now time to simplify, collect up the like terms on top. I've got a 2x and a 1x, that makes 3x. And I've got a 12 and a 4, which makes 16. And then the last thing to do is check, can I factorise that numerator? I can't, they don't share any factors, 3x and 16. So if you can't factorise, you can't simplify. Okay, next question. Once again, we're adding or subtracting, which means we need to find a common denominator. So the lowest common multiple between 3, 5 and 10 is 30. So I'm going to go with 30x plus 30x, and then the last one is a minus 30x. So what do I need to times this bottom here to get 30x? I've got to times it by 10. So I've got to do the same to the top as well, and that's going to give me 20. I've got to times this one by 6, so I do the same to the top, and that gives me 24. And lastly, I've got to times this one by 3 to get 30x. So I've got to do that same thing to the top to keep the fractions equivalent. And that gives me 27. I can now write it as a common denominator, so all over that denominator. We've got 24 plus 20 plus 24 minus 27 is 17. And there are no factors there. There's nothing that is shared on top and bottom there, so you can't simplify that any further because 17 and 30 don't share any factors, so we're good. Okay, next question, and once again we are adding, so therefore we have to find a common denominator between 4 and 3, and the lowest common multiple between those two are 12. So I'm going to want this over 12, and I'm going to want this over 12. So for this one, I need to times that by 3, so I've got to do the same to the top, in brackets. So this gives me 3 lots of 2x plus 1. And this one over here, to make the bottom 12, I've got to times that by 4. So in brackets, I'm going to times this by 4 as well, to get 4 lots of x minus 2. Now I can write that all over 12, and I can add, I can expand out and then add my numerator. So this is going to give me 6x plus 3. This is going to give me 4x minus 8. So plus 4x and minus 8. And then we can collect like terms. I've got a 6 and a 4, so that makes 10x. And I've got a 3 minus an 8, which makes minus 5. And that's all over 12. And then we check, can we factorise the numerator? Well, yes, we can actually this time. So I'm going to do it just in case. So 5 can come out of the numerator to leave 2x minus 1 over 12. Now, can I divide 5 and 12? Do they share any factors? No, they don't. So in fact, I can't actually simplify this anymore because 5 and 12 don't have any common factors. But anyway, you can leave it as this one, or you can leave it as this one. Both are fine. Both are just as simplified as one another, so both would get the marks. Okay, we've got another question where we are either adding or subtracting, which means we need to find a common denominator. Now, these two denominators don't share any factors. We can't factorise them at all. So because they're both algebraic terms, we just have to multiply them together to get a common denominator. So I'm just going to write out the question again, like so. Just giving myself a bit of extra space. And what I need to do is to make these these denominators the same, I need to multiply this one by x plus 1 on the bottom. So therefore I need to do it to the top as well. And this one, I need to times this one by x minus 2. And so I need to do the same on the top as well. And now you'll see that the fractions have been manipulated so that their denominators are the same. Which means I can write it all over the same denominator of x minus 2, x plus 1. Of course, it doesn't matter which, I've written them in a different order, but because we're timesing these two things together, it doesn't matter which way round. So you could write x plus 1, x minus 2, or you could write x minus 2, x plus 1. It wouldn't make a difference. But they are the same, which is important, which means now we can add, or in this case actually subtract the numerators. So multiplying out gives me 4x plus 4. And then here's the tricky bit, which is the bit which most people will make a mistake on. I've got minus 3, so this minus here, minus 3 times by x gives me minus 3x, which most people are fine with, but then the minus 3 has to be applied to the second term in the bracket as well. And a minus 3 times a minus 2 is a plus 6. Okay, now we can simplify the numerator. 4x minus 3x is 1x, and 4 plus 6 is 10. And that's all over x minus 1, x plus 1. Now, we check the numerator. Can we factorise the numerator? No, we can't. And is this x plus 10 also on the bottom? No, it's not. So we can't simplify anymore. So that is done. Because if you can't factorise, you can't simplify. Okay, next question is it's an addition or subtraction, so we've got to find a common denominator, and then it's an equation as well, so we'll deal with that later. Let's just simplify the fractions first. So the lowest common denominator will be 20, because that is the lowest common multiple of 4 and 5. So this one I'll need to multiply by 4, so I need to do that to the top as well, in brackets, like so. So this gives me 4 lots of 9a minus 7. And then this one I'll need to multiply by 5, and I'll do that to the top as well. So this gives me 5 lots of 3a minus 7. Okay, great. So, and that all equals 4.55. Okay, so now we can make it all over 20, and we can multiply out these brackets as well as we do it. So 4 times 9a is 36a. 4 times minus 7 is minus 28. Minus 5 times by 3a is minus 15a. And minus 5 times by minus 7 is plus 35. And that's all equal to 4.55. Okay, what we can do next is we can multiply both sides by 20. And that will get rid of the divide by 20 over here, and it will make the right side 20 times bigger. So we get 36a minus 28 minus 15a plus 35 equals 20 times 4.55 is 91. Next we can simplify the left hand side, so we've got 36a minus 15a is 21a, and then we've got minus 28 plus 35 is plus 7, and that equals 91. We can take the 7 from both sides, and that will give me 84. And then we can divide through by 21, and that will give me 8 is equal to 4. Perfect. Okay, another question where we need to find the common denominator. So we're going to multiply this by 2 and multiply this one by 3 in order to get a common denominator of 6. So I write 6 and then minus and then all over 6. And if I times this one by 2, I've got to times the numerator by 2 as well. And if I times this one by 3, I've got to times the numerator by 3 as well. So I get 2 times this bracket, which looks like that, and I get 3 times this bracket, which looks like that, and that equals 13. Okay, I'll put it all over 6, and I'll expand out the numerator. So 8x plus 10, and then, be careful, minus 3 times by 3 is minus 9, and then be super careful for the last one, because most people forget it's a double negative, so that becomes plus 3 times 2x, which is 6x. And that equals 13. Okay, in the last question I times by 6 first, but perhaps it's best to simplify first. It doesn't actually make a difference, but let's simplify the top line first. So let's collect the like terms here. We've got 6x plus 8x is 14x. We've got 10 minus 9 is plus 1. And that's all over 6, and that's equal to 13. And I want to show all my steps here, because it does say show algebraic working, so there's no point skipping steps. Times through by 6 is going to give me 78. Yeah. So 14x is equal to 77. And then we can divide through by 14. So x is equal to 77 over 14. Which is the same as 11 over 2, dividing top and bottom by 7. So 11 over 2, or 4.5, is the correct answer. 5.5, nearly. Okay, these are tricky questions that Edexcel have just started putting into the exam paper, so watch out for them. They're asking you to express A, so that means that we want whatever we want. What we want is something to be A equals. And that's a good start, because we've got something that's A equals there. But it says in the form of Py plus Q over Ry plus S, where P, Q, R and S are integers. So they are just numbers, they're just constants. So we need it essentially in terms of Y, because here we've got these Y's here. So we can't have any x in our equation, and at the moment the equation which we are looking to achieve, a equals, has an x in, but we don't want an x in, we want a y in. So what we're going to do is we're going to take this x equation here and substitute it in over here. So replacing that x here with the expression in terms of y. So we're going to write it out as 14 over 3, and we're replacing the x because we don't want x's. We want it instead with what x is equal to, which is 7 over 4y minus 3. And then minus 7 because of the minus 7 here. Okay, so this looks confusing because we've got a fraction and a fraction. Now what we want to do here, simply put, is we want to multiply the top and bottom of this fraction by the denominator of this fraction in a fraction. Because we really don't like having fractions in fractions, and if we times through by that denominator, it will clear out and make this no longer a fraction in a fraction. Okay, so we're going to multiply through on the top by this, and we're going to multiply through on the bottom by this. And of course that's absolutely fine, because essentially all we're doing is timesing by 1, because we're timesing by the same thing on top and bottom. Right, so the top becomes 14 lots of 4y minus 3. Now, when I multiply this green bracket into this term here, well, that is going to cancel this denominator because we're timesing and we're dividing by the same thing. So essentially this is going to get cancelled, and what's left over is just the 3 times by the 7, which is 21. But we have to remember that there's 2 terms on the denominator, so we have to times this as well by the 4y minus 3. So this becomes minus 7 lots of 4y minus 3. And we've achieved what we set out to do. There's no longer a fraction in a fraction, it's just a single fraction, which is exactly the type of term that we want. Okay, so now it might be sensible just to multiply out. Or maybe the keen eye of you will notice that we could divide through by 7, but I think most likely in the exam you would just kind of multiply out just to try and simplify first, so that's what I'm going to do. So we do this times this, and then we do this times this, so we get 56y, and we get minus 42 over 21 minus 28y, and minus 7 times minus 3 is plus 21. Okay, right, so we can simplify here. So 56y minus 42 all over minus 28y, and then 21 plus 21 is plus 42. Okay, now this can simplify further because we can actually factorise the top and we can factorise the bottom. And if you can factorise, then there's a chance you can simplify. So what can we take out of the top? We can take out a, we can take out a 14 in fact. This might be going the long way around here, but we can divide everything through by 14. And I'm just going to show you why that's possible, because we can take out a factor of 14 on the top, and we can take out a factor of 14 on the bottom as well. And if you can take out a factor and you have a factor on top and bottom, you can cancel them out. So this is 4y minus 3 over minus 2y plus 3, and that is exactly the form that they want it in. Okay, right, I'm really glad that this question has come up. It's really informative because it is a plus, and we're going to find a common denominator therefore, and they are algebraic denominators, so some people may just multiply the two together. But that's not the way to do this question, because the first thing you should always do if you have algebraic fractions is you can see if you can factorise. And this denominator here we can factorise. We can take out an x. So we get x plus 2. And now we can see that the common denominator is staring us right in the face. We just need to multiply this one by x top and bottom, and therefore we have a common denominator. So we've got a common denominator of x plus 2, and on top we've got 5x plus 3, and that's equal to 2. So now we multiply the denominator to the other side, and we get 5x plus 3 is equal to 2 lots of x plus 2. And now we need to expand out the brackets, and this is going to give us a quadratic. So quadratics we want to set equal to 0, so I'll move all the terms over to the right hand side. I move it to the right hand side because I want the x squared to be positive. If I move it to the left, the x squared is negative, just makes it a bit trickier. So when that comes over, we're taking away 5x from both sides, so we get minus 1x when we take away 5x from 4x. And we move the 3 over, we're going to get minus 3. Okay, great. So now I'm going to do the way that I factorise quadratics, where the x squared term is not 1. I write AC is equal to the a term, which is 2, times by the c term, which is minus 3, which gives us minus 6. And the b term we write down is just minus 1, because there's a minus 1x here. So now what I'm doing is I'm looking for two numbers that times together to make minus 6 and add to make minus 1. And those two numbers are minus 3 and 2. And because this is a 2 right here, I write 2x all over 2, and that is equal to 0. Okay, so those numbers that I've just found, minus 3 and 2, they go in here. And then I simply divide through one of the brackets here by 2 to get rid of that divide by 2 on the bottom, and that gives me x plus 1 is equal to 0. So now 2x minus 3 equals 0, or x plus 1 equals 0. If it's this one, then add 3 to both sides and then divide by 2, gives me x is equal to 3 over 2. Or if it's this one, we just minus 1 from both sides to get x equals minus 1. So those are the two solutions to this equation. Okay, we've got another one of these substitution questions. So once again, very similar to the one we've just done before. It wants an expression for x, and we've already got an expression here for x. But the problem is they want it in terms of a. And at the moment our expression is in terms of y. But never fear, we've got an expression for a y, in terms of a. So this guy is going to get plonked into here. So we write x is equal to 5 over 9 lots of y, but we don't want y because we want it in terms of a. So we have to swap y out for 5 over 5a minus 2. And then we've still got this plus 5 as well. Okay, so the most efficient way of doing this question, I believe, is to multiply the top and bottom by the denominator of the fraction that is inside our fraction, because we really don't like fractions in a fraction. So multiplying top and bottom by this denominator is going to give me 5 lots of 5a minus 2. And then at the bottom, I'm going to times this into here, which is going to times this whole term. And because we're timesing by 5a minus 2 and we're dividing by 5a minus 2, they cancel out. So we're just left with 9 times 5, which is 45. And then here we've got plus 5 lots of 5a minus 2, because on the denominator there are two separate terms and we have to multiply both of them in order to multiply through by this 5a minus 2. Okay, now this time round I'm going to take a shortcut and I'm just going to divide the top by 5 and the bottom by 5. That will divide this term here by 5. It will divide this term here by 5 to get 9, and it will divide this term here by 5. So that gives me a numerator of just 5a plus minus 2. On the denominator, I've got a 9 plus a 5a minus 2. So this way, a bit more efficient than the way I did it last time, but both are good. And then 9 minus 2 is plus 7. Okay, and that is exactly what they want it as, a single fraction in its simplest form, as they've asked. Perfect. Right, on to the beast questions now. So this is 23, question 23, so right at the end of the paper. And we need to use BIDMAS, and we need to factorise as much as we possibly can. So BIDMAS tells us to do bracket first, and we want to factorise as much as we can. And this is a difference of two squares. So this is x minus 6, x plus 6. Because whenever you have two squares like this, like an x squared here, and 36 is also a square number, and we're subtracting them, then as we know, a squared minus b squared is equal to a minus b, a plus b. Difference of two squares, dots as some people like to call it. Okay, and now we're taking away two lots of, 2 over x minus 6. So inside this bracket, I'm going to want to subtract these two fractions, which means we need a common denominator. And now we can see that the easiest way of doing that, because we factorised, is just to times this one, top and bottom, by x plus 6. And we get a common denominator. Okay. Now what I'm going to do is, even though I'm focusing on the bracket first, I'm still going to write times by 1 over 4 minus x, so that my work is neat and it just follows a pattern where we're expressing the whole thing as one, rather than doing it in like bits and bobs. So it makes it easier for the examiner. Okay, so now we can write a single fraction, because we've got a common denominator, and we can write the numerator as 20, and then we'll multiply this out. So minus 2 times x is minus 2x, and minus 2 times 6 is minus 12. Okay, and then afterwards we're going to multiply by 4 minus x. Okay, fine. Let's simplify that numerator, and that becomes 8 minus 2x over this x minus 6, x plus 6, and then we're going to multiply by 1 over 4 minus x. Equals. Now, again, what did I say? At any opportunity, if you can factorise, do it, because factors are your friends, and we're going to want to factorise as much as possible. So we can take out a factor here of 2 to get two lots of 4 minus x, and that's all over. Okay, so that's over x minus 6, x plus 6. Then we're multiplying by 1 over 4 minus x, and as expected, we do have a common factor on the top and one on the bottom. So because the numerators are going to be times and the denominators are going to be times, they all become glued together by multiplication. So this is a factor of the top and this is a factor of the bottom, so they can go. So overall, now we just have 2 on top, because 2 times 1 is 2. And we have x minus 6, x plus 6. And that is good. You could expand out the denominator if you wanted to, but factors are your friend, so keep it factorised. Okay, the beast to finish. So the first thing we're going to do is factorise, because factorising is good. And we have got two squares here and the subtraction in between, which is difference of two squares. So I'm looking for the square root of 25x squared, which is 5x. And the square root of 64, which is 8. So by difference of two squares, this factorises to make 5x minus 8, 5x plus 8. Okay, the next one, this is a quadratic that needs to be factorised. So I'm going to use my method, which is take the a times the c, which is the 5 times the minus 6, and take the b term of minus 13, and then look for two numbers that times to make minus 30 and add to make minus 13. You might be thinking 3 and 10, but that's not right, because that doesn't work because of the signs. It's actually minus 15 and positive 2, because one of them has to be negative, one of them has to be positive in order for them to times to make a negative. Now because the a term is 5, I write 5x all over 5, and I put those two numbers in, minus 15 plus 2, and then I divide by 5, and I can do that by just dividing this one bracket here by 5, and that will divide the whole thing by 5. So that goes on the bottom. X minus 3, 5x plus 2. Perfect. And then we are multiplying by this bracket here. A bit conscious I might run out of space. Let's just shift that up a bit. So then we are multiplying by this, so that can be factorised. Now this is just a single x squared, so this will be definitely x, and timesing to make 15 and adding to make minus 8 must be minus 3 and minus 5. That works. And then that's all over 5x plus 8. And then, let me get rid of this, now that's done. Whoops. Let me get rid of this, now that's done. And that's all minus x minus 7, which I will write as x minus 7 over 1, because it's just nicer to have them all as fractions. Okay, good stuff. Now what we could do is, again, follow BIDMAS. We're going to want to multiply first. So let's look at this multiplication and ask ourselves, all of the tops are going to be multiplied together and all of the bottoms are going to be multiplied together. So are there any common factors on top and bottom? So they're all factors because they're all multiplied. Now that one and that one, they can go. And this one and this one, they can go. And that's it. So now let's multiply them together. So 5x minus 8, x minus 5. And I do not want to multiply out just yet. And then 5x plus 2. Perfect. And then we're subtracting x minus 7 over 1. Now, what's the common denominator? Because we're having to subtract, we need a common denominator. Well, I would really like this denominator here to be 5x plus 2. Well, let's make it so. Times through by 5x plus 2 on the bottom here, times through by 5x plus 2 on the top here as well. Lovely. Because we're timesing by 1, we don't need to write it. Now we've got a common denominator, which means we can write this all over that denominator, which is 5x plus 2. Okay, now here comes the tricky bit. The numerator, we're going to have 5x minus 8, x minus 5, minus, critically, x minus 7, 5x plus 2. Now we're going to need to expand that numerator and then collect it all up and then check if it has any factors that we can take out to perhaps simplify further. So numerators, we do need to expand them if we've got this subtract or minus sign in between, because we need to check to see if there are any factors. So expanding the brackets, x squared, sorry, 5x squared minus 25x minus 8x plus 40. And then we're going to minus, and when I'm minusing a double bracket expansion, I just want to keep them in brackets because I don't want to make any mistakes. So this is going to give me 5x squared. This is going to give me plus 2x. And then we're going to get minus 35x. And we're going to get minus 14. Okay, now let's look to simplify, because that's all over 5x plus 2. Okay, so straight away I can see a 5x squared and a minus 5x squared. Lovely. Let's look at the x's. This is going to give me minus 33x, and then I'm going to have the plus 40 as well. Here I'm going to have a minus 33x, because 2 minus 35 is minus 33, but it needs to be negative. So it's going to turn it to positive 33x. And over here we're going to have a minus 14, but that needs to be negative as well. So it's going to turn it to a positive 14. That's all over 5x plus 2. And then here we've got a minus 33x plus a 33x, which are going to cancel out because that makes 0. So that allows me to then simplify the top to become 54, and that is over x plus 2. Job done. Hope you enjoyed that. I'll see you in the next one. Bye for now.